All right, so we'll solve logarithmic equations today. And our goal will be to get a logarithm isolated, so then we can do the inverse of the logarithm to cancel it, and that's going to be an exponential. So the goal here will be to make this the exponent of 4. But before we do that, let's move the 100 over there. We're going to subtract 100. We go 1100 minus 100. Then we'll divide by 500. And to cancel log base 4, we'll make these things the exponents of 4. That's called exponentiating. And we get g and 16. And it does work. Log base 4 of 16 is going to be 2. 2 times 500 is 1,000 plus 100 is 1,100. Pause the video and try that. And sometimes people get creative and they'll divide by log. Well, log is not a number. We can't divide by it. And this isn't multiplication. So remember, we have to remember what the base is. The base is 10. Okay, and if we substitute that back in, it will make the original equation true, so that's a solution. And here's a different type of equation. We have several log expressions, so we have to combine them to isolate an expression. And here we're going to make this, turn this into one expression because it's log minus a log. So this will end up being, when we have subtraction, we'll turn that into division. And now, since we have the log of the same base on both sides, we can just exponentiate. So this and this both will be the exponent of 5, and we'll get x equals multiplied by 4 and subtract x. And if you put 2 into the original equation, it will be equal. Pause the video and try that one. Exponentiate with base 9 to cancel the logarithm. We'll do the fourth root. And both of those are solutions. They will both work up here because we're going to do the fourth power, so that means it'll be, whether you put a positive or a negative there, it's still positive. So here we're going to try to get to the same point. We just have one new thing, and that's that 2, so we want to make sure that moves up to this before we combine. So make sure that we don't just turn that into a 4 when we move the 2 up. This 2 applies to the whole argument of log, so it's applying to the 3 also. So let's do that. Let's square this 9x to the 4th. And we have subtraction, the difference of logs, so that's going to turn into a quotient. All right, and we're going to make both of those the exponents of 10 because this is log base 10. Now we just have a rational equation, so let's multiply by by the denominator, and if we distribute this 2 times 5, we're going to get a negative 5 and a positive 8, so that's going to be a positive 3 minus 4. This is going to cancel. Let's move this over. Subtract 9x to the 4th. Now we have this pattern. And we could think of that as being u squared plus 3u minus 4. And we can factor that to u minus 1, u plus 4. which we have u minus 1 equals 0, u plus 4 equals 0, u equals negative 4. And this is going to be u replaced x squared. So this is x squared positive or negative 1. And here we get positive or negative 2i. We will, if we check this, they both work, and we're not going to use the imaginary. So those will be the solutions. And remember that natural log is log base e, so when we exponentiate that, we'll use e. Pause the video and try that. The difference of logs, so we change it into a quotient, and then we'll have each side be the exponent of the base, and that'll cancel the natural log. Subtract 16x, add 12. And 4, 3, 16, 12, that has a pattern that can be factored by grouping. So here's one way to show factoring by grouping. And we factor the common factor here is 4. The common factor here is x squared, and the common factor is 4x, and the common factor is 3. But then we'll check for the signs and make sure they work out. 3 times 4 is 12, but we don't get a negative here if we go 3 times x squared. So make that a negative. Negative times negative is positive. And then we have 4x minus 3 equals, let's not write that yet. 4x minus 3 times x squared minus 4 equals 0. Do the square root of both sides and we get that. And we get 3/4 and positive or negative 2. If we check all three of these numbers, remember that this is, we have to check 2, we have to check negative 2. 2 is the only solution, and this is extraneous, and so is that. All right, stop there.